span and deflection. For a uniformly distributed load, the deflection of a beam is proportional to the span to the power 4, and for concentrated load it is span to the power 3. So just by increasing the span by 2 times, the deflection will increase 16 times if uniformly distributed load is acting on that beam. Okay, to reduce the deflection, an increase in depth of a beam is more effective than increase in its width. So here we have a demonstration that just we have increased the span and the deflection have significantly increased. And if we want to improve the stiffness of the member, or we want to reduce the deflection, so then the better option is to increase its depth instead of width. Here we have a same section and same span, but here the depth is less but the width is large. Here we have reduced the width but increased the depth. In that case there will be very less deflection. So this is the same concept as we have discussed earlier in case of second moment of area. When the width is larger and the depth is small, so the second moment of area will be less and the stiffness will be less, and as a result the deflection will be more. But when the depth is larger, second moment of area will be larger and the stiffness of beam will also be large, and as a result the deflection will be less. Moreover, if we want to reduce the deflection or we want to control the deflection other than span, we can also change the end conditions. In case of simply supported beams, the bending moment at the center will be WL square over 8, and as a result the deflection will be large. But in case of fixed ended beam, the bending moment at the center will be WL square over 24. So in that case the deflection at the mid span will be less. So just by changing the end condition we can improve the stiffness or we can reduce the deflection. So here it is a simply supported, so here the deflection is large, and in this case the ends are fixed, so the deflection will be less. Here we have a practical application how we can control the deflections. So there are some trees which grow their roots naturally when they feel that their branch is overloaded or the length of the branch is increased sufficiently and it will deflect. So they will grow the root just to change the end condition or to limit the span. So similarly here, to keep the deflection of this cantilever portion within the allowable limits, we can add this support. So this support will change the end condition, and as a result the bending moment will change and the deflection will reduce. Here again we have added some support, and here we also have added some support to limit the deflection.